Hello, everybody. Well, today we're going to discuss our power board block diagram, and this is the fourth revision. What we're going to go over today is a very simple concept-only block diagram. So let's get started. Well, the input to the board is basically solar panels and batteries. And this is a solar panel. It's an external board that's attached to the satellite, and basically it has three wires coming to it: ground, power, and the temperature sensor. So what's on this solar panel board, and there's 14 of them, and they're identical, is of course the solar panel. And there's two cells in series, and the open circuit voltage on these cells is about 5.5 volts. The maximum power point voltage where the cell can deliver the most power is about 3.8 volts. So what happens is that the sun irradiates the solar panels. These solar panels produce voltage and a current, and we pass this through an ideal isolating diode. This is so that when we're in eclipse, the panel does not pull current to ground through the diode. Also on this panel is a thermistor, and this thing varies resistance as a function of temperature. So as the voltage and power get impressed on the solar panels, that comes to a line on the satellite, and we have two senses. One is a voltage sense, and we actually just scale down the voltage. Our A to D cannot take more than about 3.3 volts, so we just do a scale down here and send this to our analog sensors on the PIC. We sense current flowing in the solar cells by the voltage drop across this resistor. So as current flows from the solar panels into the load, it goes through a very small resistor, I think 0.05 ohms, generating a small voltage in the range of 10 to 20 millivolts, and we just amplify this with this differential amplifier, and we send this to the PIC. So now essentially we have 14 of these things, and they're connected all in parallel, and we call this the always-on bus. Let me see if I can get rid of this stuff. So here's how everything gets started. We have an external switch on one of the legs of the satellite. So when the satellite gets ejected from the rocket, this switch closes. When the satellite is in sun, that supplies voltage to this watchdog timer. This watchdog timer will then close the master switch, which is this switch here. So just to kind of review, is that when the satellite gets ejected, we power up this watchdog timer, which closes this master switch. This master switch now supplies voltage to three things. One is called the unregulated bus, one is the 3.3 volt regulator, and one is the 5 volt regulator. So when this bus gets energized, this produces 3.3 volts, which will power up the PIC. And here's where things get started. This switch here can also be controlled by the PIC. Now, in addition, we have three batteries on this board, and they're all similar. And these batteries are switched onto the bus under the control of the PIC. And again, we have a current sensor, and we again measure current by voltage drop across a very small resistor. Since our PIC can only convert analog to digital converters in positive voltage. If you notice, these op amps are reversed. Is that when voltage is flowing in this direction, actually the battery is supplying voltage to the bus. We generate a positive voltage on this operational amp. The reverse is true. If we're charging the batteries, this gets positive. In addition, we have a couple other interfaces. One is the antenna deploy switch. This is a high current switch capable of switching at least 2 amps. And when it comes time to deploy the antennas and the solar panels, the PIC will put a high on this FET switch, which produces a high high current path to ground through a piece of nichrome wire cutting our deal. The main interface back into the satellite is an SPI bus, and we have our typical clock, serial data out, serial data in, and clock select lines. So in general, this is in a nutshell what's on the power board. And in the next videos, we will actually go through the schematics on a sort of a drawing by drawing basis, sort of describing this. See you then.